going to pick London and Port. No, Porto is in Europe. Let's pick South Korea. So if I wanna check the columns, I will do that columns. But if I want to check all of it, I would check out the head, and then I will see what would make sense for me to combine. If I wanted to analyze both data sets, what would make the most sense? Well, I would definitely like to see the time in the year, so I could use the timestamp if I wanted to. But I would also like to see, if you think about whenever you're about to hop on a bike in a new city that you've never been to, excuse me, you definitely want to check the weather. I will not get on a bike if it's snowing in a place that I've never been to. I used to live in Washington, D.C., and I remember my first encounter riding a bike with snow. I would ride my bike to the research center that I was working at, and I would go no matter what the weather until it snowed. And then I do pay attention to the weather. So it's tricky, but that's probably an important one to determine the amount of bikes that should be available in a city that offers that as a service. And also, cities, governments make money. They charge you, I believe, by the hour, and it's about, I think in Washington, D.C., it's about $5 or $7 per hour or so. And so if you spend 3 4 hours and then there's about 10,000 bikes in the city, do the math. It's a lot of money. So they do make money, and it's important. Then the second thing that I would take is so the hour, the count, the weather, and most likely the day of the week. That might be important. Who knows? So let's try that. So I am going to take with let's see, London DF. Also, well, before I take this, I have to make sure that I'm going to take Seoul. Let's see what I have from Seoul. I want to make sure I pick ones that I can use from both of them. So here I have the season, the holiday. Okay, let's see. All right, so let's start with London. I am going to say London and then I'm going to take London DF small. That's going to be my new name. And then I'm going to take the data frame. Then to select a list of columns that I am interested in, I need double brackets. And then in those double brackets, I'm going to put the columns. So I'm going to put the count. Then I'm going to use the T1 is the one for the weather. Then I'm going to use, let's see, wind speed. Then I am going to take, let's see, what else? The season Rio. And then I need one more. So I'm going to take, let's see if I have, yep, I have the hour in that one and the hour in Seoul. So I'm going to take the hour. All right, so now I have my mini data frame, and I am assigning it. I am giving it the label London DF small, just to make sure that that works. Let's check it with the tail. I am missing a D here. Excellent. So we have our mini data frame, and it works as expected. So now I need the same for Seoul. So I'm going to have Seoul DF small. And then I am going to select the exact same variables. So I have the count, which in Seoul is called rented bike count. Very annoying that is not in lowercase and without spaces. So then the next one was, the first one was the count, the second one was the temperature, which that might not work because it probably won't understand that question mark, but let's see. And then we had the wind speed. And lastly, oh no, we need two more. We need the season and the hour. So season, seasons, and then hour. Just to make sure that works well, we check the head, and now we have both of our data frames. What we want to do is that we want to rename this one in the same way as we have renamed the first one. So that way we know that we can have them together. So what I'll do is I'm going to do a quick hack, and I'm going to say, or a way of doing it faster. So I'm going to take the columns, and I'm going to replace them because they are ordered in the same way in which the London DF is ordered. What I'm going to say is, I am going to substitute the columns for, so these columns, I'm going to substitute them with the same columns as London DF small. And now, if I check, actually I can copy this same line and I can add one more equal sign and I can make sure that they actually work with a truth. And then there's true, true, true. Now they both have the exact same columns, and now I can use my function. So order and merge. Let me see if I ran that function earlier. Yes, I did. Order and merge. I need two data sets, a list of data sets. So I am going to use those two data sets. So Seoul DF small and London DF small. Oops, DF small. And then if I check the output of my function, takes one positional argument, but two were given. Oh, it's a list, sorry. That's right. Put it into aha. I should have taken the date variable. Let's see. Date, pick order, sort values, date. And hour. So timestamp is one here, but what we'll do is we will add date here, and then we'll make it, we're not going to do this for our command line tool, but we're going to add it for this one. So if we add the date as none, and say we don't need to rearrange it because they're both already arranged, so we could do if date, then it will sort it. And what we need to do here is change the date for this input here. But if it's none, then it's not even going to care. It's only going to concatenate both because they're already ordered. Again, this is not going into our command line too, but to account for the fact that we selected 5 out of nowhere and local variable new list reference before assignment. Hold on. Okay. Data list, pick order. Aha, there is this new list as well that we should take. So, else, new list is the same as data lists. Now we can actually check whether those two work or not. And there it is. Now we have both. So London had about 17,000, I believe. And then Seoul had about 10,000. So that's 26,000. We have both. Perfect. So now the last step of the puzzle, and before we go into a break, let's talk about quickly the command line tool that we're going to have for the transform spot. So same as before, we are using the typer, and then we are importing two optional type hinting types from the typing module. Then we're using the save data that we used from before in the extract module. So I need to remember to not try to read in the file as a CSV while it's a Parquet file. Now we have the optionals. So this is something else that I found out. If you want to provide a required argument and you already put in the type, you can also pass in the ellipses, the three dots, and typer will understand that that is a required argument. Even if you want to make it explicit, that is an option that should pass through the command line. So that's another option that we can take. So at the very beginning, we are taking the path in. Where did you put that extracted file at? Second, get the dates. We need them. Third, if somebody puts a column list here, then we're going to do a one-hot encoding. Otherwise, we will not. Lastly, clean the column names, add the location and place, and then save the data somewhere where I tell you to. We're going to save that file into our data engineering module that is going to be called transform.py. And then we can open up our command line tool, and then we can make sure that our transform function works. So we're going to do Python src in the source directory, data engineering, transform.py. The first element we have is path in. So we're gonna put each one of those into a different line. So we're gonna remember that. We're gonna have a dash as opposed to the underscore. So we're gonna have the path in. We're gonna say, all right, so take in from this one, out of all the files that we have, take in the one from the last section, which was the Parquet that we saved, and that should be in. So the path is data, then raw, and then testing CLI, and it's still called CSV. I'm actually going to use it with the CSV, just to showcase that it was supposed to be a Parquet file, but it is a CSV here. Then slash, dash dash, path. Date column is the next one. So what is the date column of this file? Date call, I think for Porto, it should be date, but let's see. Nope, for Porto is DTE day. So this is the day column. Then what do we need? We need an hour. What is the hour for the hour column is HR. Oops, I need to put this one here and nope, I missed this one. So our column is going to be HR. Then we go to the next one. We need remember that if we add the the columns list, then we're going to be doing a one-hot encoding, but we don't necessarily need to. Let's check that it works. we're going to put a place. So this one is for Sol. So dash dash place. Sol. And then the path out. That's going to be the clean folder because we are doing the transformation part. So data, Sol, and then interim. That's where we're going to put the transform one, not the final one. So that's the path out. Then we're going to go to the next one, and then last line is going to be the file name. For the file name, we're going to use clean or CLI test clean that parquet, and that should tell us. Remember, we have a little command here that says data extracted successfully, but here we should put maybe extracted and transform successfully. We run that cell again, and then now I must have misspelled this one. Oh, but I wasn't using the Porto one. This was the Sol one. So here it says CLI extract. This is not Porto. This is Sol. For Sol, the date variable is date, and the hour variable is hour. And then now we have it ready. It's good that it gives us an error if it doesn't work. And now file extracted and transformed successfully. Let's make sure that actually works. We use the file name CLI test clean parquet. I'm going to copy that. And then I'm going to read it with pandas. Parquet file. Let's make sure that works. 2 out, or 1 out, then data. Sol, interim, CLI test clean parquet. Let's see, that should work. There you go. And let's make sure that we have the columns that we need. There you go. We have the functioning day. Yeah, well, we have the month, the week, the day of the week, the month star, and the location ID. Perfect. All right, so it is 4 p.m. Let's take 10 more minutes, a break for 10 minutes, and then we'll be back at 4:10. And we're going to close out this section and then jump into the other one. Through this one, because it's being recorded, you can always come back and see it. And then at the end of it, if you need help with anything, I'm going to stick around, and then I can help with any questions you have and whatnot. All right, so the next thing I mentioned is sometimes it's quite tricky. If anybody here has ever tried to put data into a database, it can be quite tricky to create the binding that goes from the data, the type, and then what the database is supposed to accept. Sometimes those data files that we're using or where the data is coming from is just not coming in the right way, or it changes on us, and then the next thing we know is that whatever we're using to put data inside, to write data into a database, is just not working anymore. So IBIS just completely changes that over its head. So what it does is, for example, here I'm using ibis.docdb.connect, and what it's doing is that it's creating an in-memory database for us. But in this case, you can say in memory, and then it just keeps it in your session while you're working, or you can create a path to it, and it will create what we will call our data warehouse. So if we were to go to data, and then we will see data warehouse over here, or the warehouse, it will be analytics.db. This is what we would want to call it. So IBIS would take the path in for any data frame that we have created, either a CSV or a Parquet file, and it will take the mapping of that, and it will add it into our database with a table name. So how cool is that? We don't even need to put the question mark, or create table as, or create or replace table. Like, you don't have to worry about anything of that. All you do is plain code. So it takes the table name, it puts in the data frame that we're reading in, and off you go. And then, so we're going to test that. We're going to make sure that that works. And just so that you can see, I'm actually going to delete the analytics.db, or I'm going to use, actually I'm going to use a new name that is not even here. So I'm going to take the Porto Parquet file, and I'm going to add it to a path. Let's see, the data path. I'm going to go to the warehouse, and then I'm going to add, this is going to be the file name, and or this is going to be the new database, and I'm putting DDB for DocDB, and then I'm going to tell 1 day. I don't know why I put 1 day, but it is what it is. All right, so let's check that that works. And background error, SQL, Alchemy. Ooh, okay. I still have a connection open for SQL Alchemy, so let's close that. Let's restart this notebook. And then I have to import pandas again. So instead of doing it like that, what I'm going to do is, actually I don't need to import pandas again. I just need IVs. Okay, so here is my function again. Let's see that this works. Data path, that is what I'm missing. Data path equals data warehouse. There it is. So that's my data path. And now that we have it, so here we have, oh, it has to be a path from pathlib import path. Okay. I did not add the path here. Current working directory. I'm going to go one parent up, and then go to the data tab, and then go to the data warehouse. That is not where Porto is at. Ooh, the beauty of the... So this goes to Porto, but this is the parent. This is going to the data warehouse. This should work now. And no. There you go. Okay, so what I used here was, for the path out, I was already assigning a path. So this one did not need it to be connected to anything. It just needed to be a plain string as to where the data was going to go at. So now that we have successfully loaded the one day table, we can see in the data warehouse that now we have a test DDB, and then there's a DDB wall. While you are connected, while you have a connection to an open database, you are going to have a temporary file that is going to disappear once that connection ends. So if I restart the notebook, then that's going to disappear. Now, needless to say, if we want to check it, docdb, then we say not archive, but I'm actually in data and the warehouse. If I want to check that that actually went through correctly, then there you go. I use docdb to query my table, and I have exactly what I was expecting. So we have two more functions. One is create parquet. The create parquet is exactly the same, pretty much the same as the one as save data. But save data, we have a data as a placeholder because we were including it into the extract and transform parts of our pipeline because we needed somewhere to put the data that we had in transit. So we're going to include them both. The last step is the same one that we have been seeing the whole day. Write file, we put all the three, we create a main function, we give it a kind argument so that we know whether it's going to be, we want to save it as a database, as a new table in a database, or we want to save it as a Parquet file. Then we say, could not understand argument kind, please use PQ for Parquet files or DB for database. And then data extracted successfully. So we overwrote our file. We can check it in the command line, but I leave it up to you to check it in the command line. The last stage that I had for everyone, and let me check the time. We have about 13 minutes, so we still have a bit of time, or for at least to cover this part. When you have data version control, you are essentially sending files, creating a hash or a mapping for one file, or you're creating some sort of encoding for a file. You send that file over the network somewhere else, for example, to your Google Drive, to your S3 bucket, or anywhere where you're going to be using that file at, and then DBC keeps track of what happens and what changes happen to that file. It's pretty cool the way it happens, but as you can imagine, with many, many gigabytes, it can actually get a little bit slow. But nonetheless, that's not the only useful tool that it gives you. The other useful tool that it gives you is that it allows you to create pipelines. And these pipelines are stages that allow you to track the workflow, the inputs, and the outputs of such. So I'm going to give you a quick example. I already have DVC in it. There are a few commands that you want to make sure you understand well. If you know Git, most of these are going to be very, very recognizable. For example, the DVC init, you can do that after you have installed DVC and after you have initialized your repository. So now you're tracking your file. Now you can start tracking your files. DVC remote add allows you to put a file storage somewhere in the cloud, and then you bring it over. That's where you're going to be putting your files at. DVC add, point towards the file that you want to keep track of. DVC push, send it to that remote repository, DVC pull, get those changes. The cool thing about it, just how you guys have, how all of you have been doing git pull, the couple of times that I've made a commit, then in the same way, if I was to change a file, a data file, you could do DVC pull, and then you will have the files with you. Of course, because the internet is slow, it was much easier to do it all in the git clone than to do it with the DVC pull. DVC stage is the thing that the command that we're going to use to create that pipeline. And then DVC repro is reproduce my pipeline, create that pipeline. DVC DAG will show you a graph in the command line of where your process starts and where it ends. So how do we do this? So we're going to do it quite quickly because we have about 10 minutes left. But let me show you what the output of this is going to be. You're going to have a DVC YAML file, and then that file is going to show you your stages. So you have a stage, so extract, the same Python command we ran with our typer function. Now we're tracking the data, now we're tracking the code, now we're tracking the output. Then the second one, so transform, the same one we just ran. The third one, so load, the same one we just ran, and then we're putting something in the analytics database. And then just so you know that this can be done in this way, I'm actually going to remove all of the files. So for DVC creates a DVC directory where it creates a config file. That config file has the settings of where you're going to send data to and what you're going to do with it. And then the other thing that it creates is this DVC.yaml and a DVC.log. The DVC.log is more non-understandable. It's sort of like the hash that it keeps to make sure it's attached to that file, and if it changes, the file change. So what I'm going to do is I'm going to delete all of these ones, and I'm going to start the project as if it was from zero. So DVC ignore, DVC YAML, and DVC log. I'm going to remove all of those, and then I'm going to do DVC init. I'm going to create a new repository for DVC again. And then what I'm going to do now that I have initialized it, I'm going to use the commands that you saw a second ago. Notice that every time you start a repository, DVC gives you this. It tracks usage, and you can disable it if you want to. It's not like they're tracking you, but how many times it's being downloaded and such. So then I'm going to start adding stages. And I'm exactly going to use the commands that we just used. The thing that you need to remember is that you're adding to a stage a dependency. What is that dependency? Where my CSV file is at. Then you're adding a row, a output. What is the output of this function going to be, or this command line to? Is going to be the clean file, or the extracted file, or the transform file, and so forth. Do you have any weird encodings and so forth and so forth? Well, maybe. So I'm going to add this stage. I'm going to paste it here exactly as is. Now notice that DBC is going to tell me, well, with your Git, you should start tracking the dbc.yaml that I just created for you. Also, if you don't want me to tell you this stuff every time you add a stage, then you can just say auto stage.true. So now you can see I deleted the YAML file a second ago, but it just created one again for me, and it did it with the same dependencies that I gave it a second ago. So I'm going to go and copy the next ones, just so that we can all see how the pipelining work. So we created a folder that, given a proper setting or a requirement that's .txt and a setup.py file, we will create a module with it. We attach a command line to all of those three modules. Then we created a pipeline with DBC, and now we're tracking the data and the code with Git and DBC. So now we're at like sort of the last stage of how we can create our own data engineering workflow without having to get fancy tools or pay millions of dollars. Or not millions of dollars, but you get the point. So now we have the second stage, which is the clean. And then I had an exercise for you to create the last stage, but I'm going to use it here. And then the way in which we run our stages is DBC repro. And let's see, data, so, okay, so DBC YAML. So is actually in the raw folder. So I'm going to save that. I'm going to rerun that. Okay, let's see. The last one, transform. Row. I gotta add another row here. And that should be, and then lastly, the beauty, the demo gods are definitely against me today, as you can see. So the Python source, db, path, so interim, so clean. The good thing is that once you create in programmatically this DBC reproduce my pipeline, then you can see that you can go into the YAML file and change everything as opposed to running all the commands by yourself or on your own. So what I'm missing here is the, let's see, so interim so clean dot parquet, which is the last one there. Then data warehouse name analytics.db, table name so main. Aha, so it's not name, it's table name, analytics name, let's see. Table name and file name. And in my DBC YAML, I have name. Let's see. Create DB. Table name, file name. Okay, perfect. So it is file name, and that should be the very last one for the repro, hopefully. And voila. So now we have all of the files that DBC could track. And if you want to evaluate what the lineage of, and by the way, I will do the updates with the with the things that I updated from the notebook. I'll push the updates today, tomorrow. So make sure you do a DBC pull and you see the latest changes on this notebook. The instructions do walk you through every step, everything step by step, if you want to walk through them. Of course, because I change so many things as I'm going, I change the things the entire time. But DBC, DAG, then we can see that we extracted, we transformed, and we loaded some data. And now, not only can we see this, but we can also start tracking with DBC add. We can start tracking our data. Our data is already being tracked. And the best way to see this is that now you have a DBC ignore file. This one doesn't have anything in it, but if you go to, let's see, so if you go to the SO, DBC already put a git ignore into your folders because you never want to commit data and then send it towards send it to Git because Git would explode. It has the Git LFS, but obviously that can only take a certain amount. So if you want to send it to an S3 storage or something like that, then that's where you want to put it. So you get DBC, Git ignores it for you, and you can do auto stage, and then you will start tracking the files for you immediately. So once you do Git add, then you're adding those files that you're tracking. When you do DBC push, you push the files that you are tracking. Okay, so with that, there was only one last point about this section. We got about 2 minutes left. So the DBC repro, DAG, DBC push, then scheduling. The best tool for scheduling, if it's on your own, is cron. I believe there is an option available for Windows users, but for Mac and Linux, it's cron. There's a great tutorial there that I added. I added a couple more exercises that definitely feel free to go through. They make sure you understood the concepts covered in the notebook, and again, it's super comprehensive, so you'll be able to see them. And then at the end, I put some of my favorite resources to learn about all of the tools that we have touched on today. So there are links over there and a bunch of other stuff. Sadly, we didn't get to the second notebook, but I hope everybody took something out of today and you're eager to do a bit more data engineering on your own instead of counting on like super fancy tools. You can always do this stuff yourself, and then you can always move to the fancy tools as well. So thank you very much, everyone. And if you have any questions, let me know.
That was a nice talk, actually. I really didn't get the explanation about the typer on the dash and underscore.
Oh yeah, okay. So if your functions, in Python you cannot have a dash. Like functions and parameters can only have underscore. They can only start with letters. They can be capital, lowercase, or uppercase, but they cannot be numbers, right? And they cannot have spaces. So you cannot use a dash in the name of a variable or a parameter. But then, for some reason, the way in which Cypher translates arguments or parameters for functions is that if they have an underscore, you will put it in a dash. So that's just a framework decision. It's like nothing that we can do about it. Yeah. So it's not. It was a design choice for us.
Yeah.
There's a lot of command line tools. If you think about it, they have a dash whenever they're supposed to have a space, or if they were to have a space or an underscore, they will have a dash usually. So I think it's just to keep it consistent with what's out there.
Thank you so much.
I've seen in the example where in case that we're using a CSV file, so most of the time we have the header columns, the header part, right? But there are some CSV files where there are no headers at all. So in this case, is there any way there in the code that we can manually define those?
Yeah, so there is. So you remember that in the code, and I should have left this attached so that you could see it. But in the code, we put ** keyword arguments, keywords. So the reason we added that is because we don't know how we're going to get the data later on, and Pandas already comes with a lot of functions that can help you parse those. So for example, if you don't have columns, it has an option that I think is called C names or call names, and then you can pass a list of the column names that you want. So you can do that yourself if it's not available. And also, if a lot of times this happens, if you're reading a CSV file or an Excel file, that the columns, the column names are actually in the second row. So you also have the option to skip rows. So you will skip the first one, and then it will go to the second one, and it will take that row as the column names. So it's it has a lot of functionalities, but you can customize it however you like.
Thank you for that.
Any more questions? Okay.
First, thank you for that very insightful talk. Is DuckDB the all-up equivalent of SQLite?
I think it's a good question. I think they consider. I can't remember if they consider themselves the SQLite for analytics, or if I just read that in a LinkedIn post or something like that. But they are pretty much like very. If they don't claim to be the SQLite for analytics, I feel like they are. It's impressive the speed of DuckDB and just the performance it has in comparison to other tools.
Would you recommend it against because mainly the challenge of the analytics team, especially when they're starting out, they are starting a data warehouse using the traditional OLTP tools. Would you recommend it against, let's say, you're setting up a data warehouse in a open source Postgres versus the DuckDB?
Oh, I I wouldn't recommend any data warehouse to be in an OLTP. In an online transaction, OLTP, I forget the acronym, but yeah, so a transactional database, they're not ideal for analytic workloads. So anything that is columnar will be preferable than something that isn't. That would be my first, that would be what I would suggest there.
I mean, given if the budget is a issue, so would you recommend DuckDB
Well,
instead?
if you okay, so that's a good point. If you only have, but if you want to keep everything centralized, and say for example, all you need to do, so you already have a database set up, and then all you need to do is to just have new tables in it that have your process data, and you want to keep everything centralized because you can manage costs better, and you can do, I don't know, you have more. Your engineers are comfortable with it, then maybe that works. So it's a particular use case, but if you want to decouple analytics with your transactional databases, then I would definitely recommend looking at options such as analytical databases. And also, the other thing is that you can compress them better, so you're also saving in space. So I think you can reduce the space maybe even 10x from one regular database, transactional database, to an analytical one.
So, yeah, also, would you recommend to substitute DuckDB versus the usual data manipulation in Pandas? Let's say you only have a 8 gigabyte data, 8 GB RAM versus then you have to process a 100 gigabyte data.
Oh, that's a very tricky one because you're talking to a person that is not very SQL friendly. Like I can write you a SQL and I can select everything from a table, very very good. But other than that, like I'm not the greatest SQL writer. I can definitely write SQL, so I have a bias towards pandas and towards tools in programming. So that's why I really like the new tool called IBIS, which allows you to just translate any kind of query into its own database. So that's pretty cool. Now, I just don't know how to do some things that I know how to do in pandas, like data manipulation and cleaning of data. I don't know how to do it in SQL, so I wouldn't substitute it 100%. Now, here's the cool thing. There are a couple of bindings or a couple of functions that allow you to use certain, say for example, pandas lingo functions inside DocDB that I've seen. Don't quote me on it. And like if that's the case, then DocDB seems to be pretty cool to just run with it because it's so much. It has such better performance. So much, yeah. The performance is so much better than pandas or than regular code. So yeah, if you see the use case and you want to live in SQL, then stick to DocDB. And if you run into troubles, then move back into programming with Python or with pandas or something like that. If not, then it's a choice.
So, I think last question for me. So, about DuckDB. Is it limited only based on the size of the hard drive, right? So, because it's not kind of a
Because it's
distributed
in memory.
storage. Yep.
Yeah, I would say so. Because it's in memory, I would say so. But like, I'm not an expert in it, to be honest. And but I've heard of use cases where the amount of data that companies have been able to analyze with DocDB because it's in memory, like just opening up a really beefy instance in AWS and then running with the data in memory is unbelievable. So it's definitely worth checking it out.
Thank you.
Yep, no problem.